In this video, I will demonstrate how to find areas under the standard normal distribution. And this is based on a question I received about a homework problem that is asking us to find, or to first sketch a picture of an area under a standard normal density curve and then find the corresponding area. And so the type of problem, or the problem statement, looks like this. And I'm making this problem up. So what this says to a mathematician, what the notation says, is find the proportion of z values between negative 1.56 and 2.25. And keep in mind that we're thinking about probability in terms of relative frequencies. So in a way, we could think, well, if we sampled these z values randomly from this distribution, what proportion of the time would we get a z value between negative 1.56 and 2.25? So the first part of the problem is to draw a sketch. And again, the z distribution, or the z variable in statistics, we reserve to represent the standard normal distribution, or we call it a standard normal variable. Sometimes it's referred to as, sometimes we talk about z-scores. That was in chapter 6. So again, I'm just going to focus on how to do the problem. So the first part is to draw a sketch. So I draw the bell curve, standard normal distribution. So the distribution is centered on 0, and then I'm scaling the horizontal axis with the integer values 1, 2, 3 to the right, and -1, -2, -3 to the left. And for the standard normal distribution, each integer value represents one standard deviation. So that's what the sketch would look like. So then the second part of the problem is to find this corresponding area. And to find these areas, we're going to use the TI calculator. And I'll demonstrate how to do that now. So if you look at the calculator's keyboard, notice the variable key, vars, right here. And what the second function for this key is distribution, DISTR, which is the second function operation here. So I press second and then vars. And these are all distributions that are built into the calculator. Notice you have two choices here. You have normal PDF and normal CDF. And a common mistake is to use normal PDF. But normal PDF does not give areas. We use normal PDF to draw curves. If we wanted to use, we could go in, for example, to y equals, use normal PDF to draw a normal or a bell curve in the graphing window of the calculator. But that's not what we're trying to do here. What we're trying to do with this problem is find the area. So I choose normal CDF. Now the way normal CDF works, and again, for any kind of technology, computer programming, calculators, what have you, the syntax is important. How you enter these numbers is important. And so for normal CDF, the syntax is to first enter the lower limit, or the lower boundary value for the area we're looking for, which in this case is negative 1.56. And another place where it's easy to make a mistake here is to use the subtraction key rather than the opposite key. So this key right down here means take the opposite, or this is how you would put a negative number into the calculator. So we want negative 1.56. The upper limit is 2.25. And the mean would be the next number we enter. And then a comma, and then the standard deviation. And again, this is standard normal. So we enter 0 for the mean and 1 for the standard deviation. And we find that that area is about 0.9284. So this is one type of problem where we're looking for an area in between two boundary values underneath a normal or a bell curve. Some of the other problems, though, in this homework problem, we're looking for areas in the tails. What we sometimes refer to them as left or right tail areas. And an example of that type of problem would be something like find the proportion of z values that are, say, less than or equal to negative 2.3. And again, the two parts of the problem are to first shade the area, or sketch the graph and shade the area. You want to try to draw as nice of a bell curve as you can. So negative 2.3 is right about here, and then we would shade this left tail area. Now, one of the things about the next thing we're going to do is find the area. One of the things that's a little bit tricky here is this axis, actually, this curve actually goes all the way to negative infinity, which is not a number. And so this is not something I can enter into the calculator. So rather than enter negative infinity, what we're going to do is we're going to enter a very small number. We're going to enter negative E99, which what that is on the calculator, what that represents on the calculator notationally, it's the same thing as negative 10 to the 99th power. And this is how we do scientific notation on the calculator. And so when I go back to the calculator to find this area, I'm going to again use Normalcdf. And for the lower limit, I'm going to use negative E99. Now the E that I'm referring to here is notated on the keyboard as EE, and it's the function above the comma. So if I press second, then the comma key, and then type 99, that's negative E99. And the idea here is this is a very, very, very small number. And what happens with all normal curves is eventually, when you get far enough out in either direction on the axis, there's really no more area left. It's essentially 0. So using a really smaller number if you're looking for a left tail area for the lower limit, or a really large number when you're looking for the tail area on the right side, will give very accurate answers. So then I put the upper limit, and then again, I would put 0 and 1. And it turns out on the calculator, if I don't put anything for the mean and the standard deviation, it'll default to standard normal. So here the area is about 0.0107. And what that means is once you get to negative 2.3 on the horizontal axis, there's only about 1% of the total area left. So only about 1% of the time would you expect to sample numbers to the left of negative 2.3. I'm going to do one more example. I want to do an example of a right tail area. And that would be, the problem statement for that type of problem would look like this. So we would have z greater than or equal to, say, 1.65. And again, there are two parts of the problem. The first problem is to sketch the area. and 1.65 is right about there. And again, these are sketches, so they don't have to be perfect. Just, do the best you can. That would be acceptable. And then, again, going back to the calculator, using Normalcdf. Not PDF. Again, it's tempting to just to press enter here, but you've got to arrow down one to get the right function. So we're going to use 1.65 as the lower limit this time, because we're looking for the area from that lower limit to the left-hand boundary value here, and then to the right. And again, in this case, we're going to positive infinity. So I'm going to use positive E99 for the right-hand boundary value. And then press enter. And see, we've got about 5% of the area to the right of 1.65. 0.0495. Now, there are a few more examples in the homework problem that I was asked about, but again, these are the three different types: the in-between areas, the left tail, and the right tail. There is one other thing I want to show or demonstrate. Right now on my calculator, I have the stats wizards turned off. And some of these newer calculators have this option for stat wizards right here. And the idea with stat wizards is that we don't have to remember the syntax. In other words, if I have these stats wizards turned on, I'll be prompted for what to input as the upper and lower limits. And so now notice if I go second vars and choose Normalcdf, I get this pop-up window. And what I'm being prompted for are the lower limit, the upper limit, mu, and sigma. And then I have an option to paste that. And what the calculator will do is take those numbers and put them all in the correct place in Normalcdf. So for this example, I would say for the lower limit, I would put 1.65. For the upper limit, again, where this area is going all the way to positive infinity, so I would use a really large number, E99. Mu is 0 and sigma is 1. And incidentally, if you just leave these blank, the calculator will also default to standard normal. But this time I'll leave 0 and I'll leave 1 for sigma. Press enter and notice how the calculator pasted all those values in where they should be. And this is an ongoing problem with the videos that I have for the course, because some of the videos were actually created before this new feature came out on the calculator. And if you want your calculator to always look like mine does, so I usually use the older version. I turn my wizards off because a lot of students don't have this new version of the calculator yet. And you can just go under the mode menu and go down and turn wizards off if you want. They're handy. I mean, once you get used to them, once you understand what they do. Okay, well, that's it for this video. I hope you find it helpful.